I'll just be running a basic introductory LaTeX seminar. It's not really become really professional LaTeX, really good LaTeX. It's more just to get a feel for how LaTeX works, how to use it, and just basic things that will help you get started. So, first of all, what is LaTeX? So LaTeX is a high-quality, open-source typesetting software that produces professional prints and PDF files. So what it means by typesetting software is that you're basically coding your document. So you're kind of, the document kind of split up into two parts, the preamble and the text. So like you type in all the backbone coding stuff to design the format of the document and kind of what elements you want to use. And the second part is really the content. So it's divided in that way. So in that way, it's really flexible. So you'll see LaTeX used in your math lecture slides, your math textbooks, like basically all scientific reports you would see, and all mathematical papers you would see online. And we'll go through a few examples as for what that looks like and advantages of it over Word later on too. So the purpose of this seminar is really to go through, first of all, really basically how to install LaTeX, to convince you why to use LaTeX over Word in some cases, and also teach you the absolute basics of LaTeX to get you started. So, in terms of installing LaTeX, we've already posted 2 links on the event page as for how to install LaTeX. There are 2 very detailed tutorials that I highly recommend. They're really good. I have the links here as well. I'll be doing a presentation later on, so don't worry too much if you don't follow too much. So, in trying to get LaTeX to work, there's really 2 components: the typesetter framework and LaTeX editor. The typesetter framework is really just the whole LaTeX package background that you need in your computer to really compile LaTeX documents. The LaTeX editor is really what you need to type up your documents. So it's two parts divided. So for an example, as for why we use LaTeX over Word in some cases, some instances. So this document is what someone has typed up using Microsoft Word. As you can see, there is a difference in font. It's not very nice. And you see that equations can sometimes blow up a line, it's not going to fit, and it looks very uneven as well. Compared to the LaTeX version, it's very evenly spaced out. The fonts match up. It looks a lot nicer. It looks just like what you would see in lecture slides. It's just like what you would see in your mathematical textbooks and whatnot. It looks a whole lot nicer. Another example. So here we have a block of text typed up in Microsoft Word, InDesign, and LaTeX. And as you can see, using Microsoft Word, you get a lot of hyphenations going on at words. Whereas in LaTeX, you only have 2 of them. In Word as well, you get a lot of instances. We can't really see it in this picture, it's cropped. But it's a lot of instances where you have a lot of large inter-word spaces. And in that way, it looks very inconsistent. And it kind of looks out of place in your text. Whereas in LaTeX, you don't really get any at all. If you don't believe me from this, we have a statistics table to really illustrate that. So, in terms of number of hyphenations, so where the words run over to the next line, in Word there were 900, in LaTeX there was only 4. The second row is with the standard deviation of the inter-word spacing. That's like how much the spacing varies. So you see that with LaTeX it's a lot more consistent with the spacing, as the standard deviation is a lot lower. Also, in LaTeX it also caps the interwording spaces, and there's no lines where the spacing is large in LaTeX. Another example, well, this is from a study that someone did where they got LaTeX uses and Word uses to type a bunch of documents, different types of documents, and they then surveyed all the uses and all of them and asked them to rate out of 5 certain descriptors, or I forgot what the scale was. But as you can see, people who use LaTeX found that they were less tired, they were less frustrated, and they enjoyed it a lot more than using Word. So clearly there's some benefit to using LaTeX over Word. So from here, I'm now going to go through some code of a basic document to go through all the basic principles, what you need to know, and how to type up a basic LaTeX document. Also, the LaTeX editor I'm using today, the one that I really like to use is called TechMaker, which is what I recommend for Mac. What I recommend for Windows, really using TechMaker or Technic Center. I really like those ones. So now, this is the text file that I've typed up the code in for this document. I'm going to run through different components of it, how you're going to set it up. So there are two parts to the LaTeX document, like I said before. You have the preamble, and you have the content of the code, or the code where you type up your actual content to the file. What are you going to talk about? So the preamble, the very first thing you should do, well, first of all, notice how I'm using a lot of percentage signs here. Percentage signs basically allow you to comment on your document without affecting the actual code. So it's like, I can just add a comment and type whatever I want. It's not going to affect the actual output of the file. It's just really to help us understand, or help you remember what certain things do. Make things a lot more clear. So the very first thing in the preamble is to define the document class. So this is really just saying whether it's A4, A3, slides, a report, an article, or whatever. In most cases, you just use an article. It's really simple. So it's just a typical document kind of thing. And then in square brackets, you have the options for that class. So it's really defining 11-point A4 paper. In the square braces, you define the actual what document you're using, what kind of document you're using. And you see that a lot of the things in LaTeX is really just a backslash and then some code, and then you define stuff. It's usually the general way of what the code looks like in LaTeX. So this is the very first thing you should do in your tech code. So once you've defined what kind of document it is, the next thing you do is the next thing is kind of optional, but you introduce packages. Now what the packages do is they allow you to run codes, run special codes, or run new codes that will do more things than what the basic package can do, and what the basic LaTeX can do. Or it basically groups together codes in nice single lines so you can use them very easily. You'll see how it works later on. So we have 4 packages that I consider essential. Many people consider essential typing in maths, typesetting maths. The very first one is called AMS Math. So we load a package by saying /use package, and the first package we're going to go through is AMS Math. And this package basically improves the structure of typed out math significantly. Second package is Math Tools. It improves upon AMS Math. Third one, fourth one, basically improve the math package in LaTeX. If you really want to find out more about these packages and really how to use them well, you should Google them along with LaTeX, and you'll be able to read a document about them and learn all the code they incorporate that you can use in your documents. But don't really worry too much about them for now. We're just going to stick to the basics. And then below we have several other packages that I also highly recommend that would also be really useful. The first one being called Geometry, and this one allows the default page margins to be altered, so you can make it really narrow, really thick, however you want it. The next one is called Microtype, and this is one I've only recently found out about, but it's really nice, really neat, because sometimes when you type up text, you find that maybe when you type 2 F's together, they're kind of too close, and it looks bad. And so what Microtype does is it adjusts all those little mistakes, all those cases where the text is really close, that it kind of merges together so that it puts spacing between them, so you can read the 2 letters clearly, and they're not too close together. And so it's just a little improvement like that. You've got book tabs improves tables, so just increasing, allowing you to make better tables. Next one's array. Paralist, this one is quite neat because then you can use 2 things called itemize and enumerate. These 2 functions, they allow you to do dot points and allows you to perhaps have an enumeration go from like 1, 2, 3, or maybe 1 part A, 1 part B, 1 part A, part I, and whatnot. You can do all those. You have graphic X, and this is what allows you to add images to your document. Color, to use colors, and then 3 other things for cross-referencing, adding hyperlinks, and then customizing headers and footers in documents. So I wouldn't recommend like going through all the packages, trying to learn all of them at once. It's really just working at your own pace, and then Googling what you need to find out, and then learning it from that, because otherwise you can't really take in all the knowledge. There's so much to learn from LaTeX. So these are all the packages that I've loaded in this document. They're what I consider essential. Next, we're going to move on to the actual body of your document. So to start that, basically say \begin document in curly braces. The first thing I'm going to do is basically define the title of the document using this command, the author of the document using this command, and also the date using this command as well. Oops, sorry, I think the text is too small. And then these are really optional. You don't need them. You don't need to define these things for your document. They just make it a lot nicer. And this next code kind of compiles all that and spits it out in your document. So you guys really haven't seen the document yet, so I'm going to compile the document now so you can see what it looks like. So you see that I can define the title of the document using this command, author, date, and this command makes it come up. If I were to delete it, it will not be there. So you need to include that command to really include all the details, or you don't need this whole beginning part to begin with anyway. Next, you can type in actual text. So this is where you would type in paragraphs and whatnot. You can type it in as usual in a regular document, but you can't really do like Control-V, Control-I and all that, Control-U to underline, italics, bold and whatnot. It's a little bit more complicated. We'll get to that in a bit. So you can type in regular sentences like so. It's a sample paragraph I typed up. And you can do different paragraphs by simply doing 2 spaces. If you were to put them, if there was only one space between them like that, you'll see that it would actually come up together. But if you add 2 spaces between them, you get a new paragraph. Also, another useful command in splitting up paragraphs is using \\. This makes it split the line into a new line. So you have, it's got a line break. Okay? So when you use this, you get a similar result, except it kind of gets rid of the indentation here. So yeah. Next, going to bold font. If you want to type up bold text, it's really using \textbs, so text bold font, and putting in brackets or curly braces, whatever you want in bold. Using italics, text it, text italics, \text it, whatever you want in italics, in curly braces too. Pretty straightforward. Next, perhaps you want to do dot points in your document. So this is where we use the itemize environment. It's called an environment because it's where we kind of define the environment when you say begin. And so this is where we just start this dot point environment. So we type this up, and note that every beginning must always have an end. So you always gotta ensure that you have these 2 components in it. Otherwise, you're gonna get a lot of errors, and you're gonna have a lot of headaches trying to look for errors if you don't type up really long code. Okay, so always ensure you have those 2 components. And then to create the separate dot points, you have you use \item for each separate dot point. Okay. And maybe you want to do like part 1, part 2, part 3. You don't just want to do simple dot points. Then you would use the enumerate environment. And so you started again by doing \begin enumerate, and using this enumerate code, we get this kind of thing coming up. So for each item, it kind of changes the number. There are ways to adjust this, so it becomes like part A, part B, part C, or part I, part 2, part 3. But I'm not going to go through that today. You can easily figure it out. You can easily find it in Google online, but this is just the very basics as for what you need to know. Also, note that you can also cluster them within one another. So you could do one part A, one part 2, and whatnot. And it's really just putting an enumerate within another enumerate to get that to happen. you do that, you get this kind of thing happening. It kind of auto-adjusts the numbering as well. It's really neat in that sense. Cool. I guess I also just went through the customization of the enumeration. So say you wanted to go from A, B, C, you can add this to the side of begin enumerate to change the style in which it increases. So this now becomes A, B, C. Okay. Next, this is more of a formatting kind of thing for your document. It's not highly necessary, but I'm just going to go through it. So you can also go through sections or make kind of titles for your documents. And the very first big one to do for articles is just / section. And let's put testing here, so you get this kind of output. You type in text, whatever you want, into a subsection. Now, I like to use tabbing, indicate that I'm working within a code within a code. It makes it a lot easier to read, a lot easier to figure out where you're going wrong in your code or to find things. So that's what I recommend you guys do. So another subsection, you see 1.1, again, it's text there. You can do a subsection, and then you can also do a paragraph within that. You can do a paragraph anywhere in these as well, which should still come out fine. It's really just formatting your document. And now next, we're looking at some LaTeX stuff. So this is what we're going to start looking at, how to type up some maths, some basic maths. So as created a subsection, how to type up maths in general. And to type out maths, you really just need to create a maths environment. So before we had an enumerate environment, an atomized environment, now we need a specific maths environment in order to type up our maths. You type up maths outside of a maths environment, say, just in this regular text, I try to type up like pi r squared. You'll see that if I compile it, I get an error saying it's missing some code, or it just can't compile because I'm not typing the maths in a maths environment. Okay? So let's get rid of this. And the very first way to define a maths environment that I really like, that I use a lot, is this. I use a backslash, open square bracket, backslash again, close square bracket. And what this does is it creates a maths environment in a new line and allows you to type up maths that will be centered, as you can see here. Okay. There we go. So you got something like this. So typing in line, or if you want to type in maths within your actual lines or sentences, you can also use dollar signs. This is also what you should use. Dollar signs make it really easy. Just add dollar signs to create the maths environment and type your maths within that. Are there any questions so far? Anything you guys, I don't know, losing track of? Yeah?
Is there a way to type in a table using the code?
Table?
Yeah.
Yes, there is a way. I'm not going to go through that, but it's you use something called tabulate. It's like another environment where you would use also tabular and use something like this to define your columns and whatnot. You can type in your table like this. But all you need to do is really Google it up and you'll find very easily how to use it. It's not all too difficult, but tabular is the one you want to go to for tables. Anyway, back to this. So here we have inline equations. So next, notice how I use a backslash pi to get pi. Really, all you have to do is add a backslash in front of a Greek letter to get what you want from a Greek letter. So for example, you have backslash gamma, backslash beta, backslash omega, whatnot, and you get all of those Greek letters. You can also add a capital in front of them to get the capital letter case of them. What happened? I'm not sure what's happening here. Sorry. Okay, but typically how you would do it is using uppercase from front to the first letter in order to get the capital version of the Greek letter. So again, using line break here, and then sometimes if you were to type up a solution, you want to join through multiple lines. And so one you should be using is the align star environment. Okay? So using this align star environment allows you to align mathematical equations in a certain way to a certain position. And so what I'm doing here is, say I'm solving a quadratic, I can align them at the equal sign by simply adding an and sign in front of the equal sign. And I use a double backslash to tell LaTeX that I'm now jumping to the next line. So say if I were to get rid of that, but I still have the new line there, it would not compile to the next line. It would be in that one line. Okay, so you need that double backslash. Again, if you forget and say the alignment symbol, the and sign, it's not going to compile properly, or it might come up with errors as well. Well, in this case, you see that the alignment is kind of shifted. It's not all aligned in the same place. Yeah?
Just you know how like when you're capitalizing Greek letters,
Yeah.
you can do it to gamma, but you can't do it to beta or alpha because
Capital.
capital beta is just like an English capital B, right? Capital
Okay.
alpha is an English capital A.
Okay.
So if you try gamma, I think that works.
Oh, what?
Yeah.
Okay, I don't remember my Greek letters, so.
And omega.
Omega
So
as
gamma
well?
will capitalize, omega will capitalize, beta and alpha just look like B and A. So you just use capital B, capital A.
Also, that's exactly why those didn't work. So the capital letter versions of those don't exist, or they're the same as English.
Yep.
Thanks for that. So you see, you can capitalize gamma and omega in this case. So moving on, looking at the code, you can see exactly what I use to type up the code. I'll type up certain expressions. So for fractions, use the backslash frac function with two curly braces to identify the numerator and denominator. To show powers, usually using this symbol here, representing a power over here. Now, if you wanted in your power, say an expression like to the power of 2x plus 1, say we were to type that out like this, would it work? See if it works or not. So it doesn't really work at all. It kind of accepts the very first term and doesn't allow the others to be on top. So what you have to do is use curly braces to identify that they're all one term or one specific element. Okay? So like that. So curly braces, they don't usually come up in your text. So they're usually for defining that a group of words or characters are together. Okay? So if you change to this, you see that it now accepts it all as one term, raised to the power of that. Let me just change it back to what it was before. And so moving on, we have the very last line a therefore sign, the therefore symbol, and we just get that using backslash therefore. You use backslash PM for plus minus. Again, these are things that you're going to pick up as you type up more and more code. It's not really things you should absorb all at once. But as you start trying to type things up, you Google it, you figure things out, and you learn it all fairly quickly. And it can also get quite complex in that you might miss braces here and there or brackets here and there in your code. It'll get very troublesome trying to find the missing bracket. And in that case, this is why I recommend using TechMaker. It automatically, well, it basically tracks where the corresponding bracket is to ensure you're not missing any of them. So for example, say I'm missing this one in my code. When I was typing it up, I forgot to add the curly bracket there. I'm going to get an error. And say I didn't know where it was, and I typed up like a 10-page document, and to find the missing bracket, it's a huge pain that I've had to do it many, many times. It's not what you want to go through. So you always want to, that's why I really recommend using TechMaker, because you can easily find out where the missing bracket is. But this is something you should try, that you should check every now and then as you type the document. And then I signify the end of the alignment environment by using \n, align star as well. Okay. So notice how in this particular document, let's compile that again, we see that the brackets are not really nice. They don't really cover the whole expression. Okay. So this is kind of it kind of goes against what LaTeX is useful. LaTeX is for really nice math documents, but this is kind of ugly. Yeah, it's gonna make it nicer. So notice how this expression here is a lot nicer. The brackets cover the whole expression, and this is kind of what you want. Okay. So to do this, we use \left in front of the left bracket and \right in front of the right bracket to get the really nice brackets that will cover up the whole term that's next to, the whole expression that is next to. Okay. Compare them, you see that this one is a lot nicer than the bottom one. Okay. We can also apply this technique to other kinds of brackets too. So we can use it. We can apply square brackets. So maybe if we change this code to \left, the left square bracket, \right, the right square bracket, we get the same thing. Well, you get it in square bracket form. You change it to maybe I don't know, absolute or the vertical line. Same thing as well. Or what if I try the squiggly brackets? So usually use this to define like one term, one unit, right? One expression. If we use this, it fails. It errors. Okay? The reason for this is the square or the squiggly braces, you should really use them if you're finding specific expressions, but you can use them in this case if you were to add an extra backslash in front of the curly braces, and it will work. Okay, so you did this, it will now work. Okay, so it works for basically any bracket, just don't use it for, or don't get the extra backslash with curly brackets. Moving on. In this math environment as well, you might want to type up text within it too. And if you just try to type up text within a math environment like so, I create the math environment again using these to censor it and to create the math environment. And I type up text like this. I see that it comes up really, really ugly. It comes up like typing up maths, but it doesn't really come out right. Okay? So if you really want to type text in your math environment, what you should be using, what you can use is the text command. Okay? So say I want to apply this within it. So I put all the text I want within the curly braces. I now get it all in text. Okay? We can even do it to specific portions of it. So say I was typing up some random maths, I don't know, a equals pi r squared is the area of a circle. Yeah? It is, well, add text within the math environment like that. Also, you might find that you want to add spaces within your expressions, within your math environment, or to basically divide words even more. So you can do this by using one of these commands, and that's really going to increase the spacing between the expressions next to it. So say I applied it here, so I added maybe backslash comma. Hopefully you see that the spacing increases by a little bit. It's just a little bit. So this from small to larger, say, if I was to add the QQ or Q quad, this would add a much larger gap. Okay? So this all is to make things a lot nicer, but to customize it to however you want it to be. Now, don't really mind this verbatim environment thing. This is just to allow me to type. I just put that there so I can type this up really nice. It comes out like code kind of format. That's all it does really. It kind of accepts the text that you type in, not as code, but as it is. That's just what you use it for. So now going through some examples of typing out some actual math expressions. So some typical things you may want to type out: matrices, vectors, integrals, trigonometric formulae, etc. These are things that you might need to type up in your courses, or that you might want to type up in your notes. Because you might be required to use LaTeX to type up assignments in second year. I know in like higher linear algebra, I had to do an assignment in LaTeX. Maybe introductory statistics in second year as well. You type your assignments in LaTeX as well. So you should really be familiar with typing up various types of formulae. So the very first one I'm going to go through is for a matrix. So for a matrix, the really simple way to do it is to use the P matrix environment. Okay, so I'm using it within the math environment because I'm typing up numbers and whatnot. Expression is going to be mathematical, and when I use the P matrix environment, it's going to create a parentheses matrix, meaning it's going to have the round brackets around it, and then I can type up my elements one by one using the AND symbol to separate each element. So doing this, I get the first row using double backslash to signify that I'm jumping to the next line, and then doing the others like so as well. Okay. Now you might find some people typing it up a really ugly, messy way, like some people type it up using like an array, defining each individual columns, and then before that even adding a left bracket, a right bracket and whatnot, and this is a lot more confusing, but if you use P matrix, it does it all at once, and it keeps your code very simple and neat, and it does it all very simply. Next for a vector. So we have a vector. You know that we can also do bold text within the math environment. And the difference between a text environment and a math environment is that in the text environment, notice how we use text VF. Text VF meaning we're going to change some text into a bold font. But in the math environment, what we do is we now use math VF, so changing some math text into a bold font. Okay, I'm going to make X the bold font to signify a vector, or you can even use \vec to get an overhead arrow over your X to show it's a vector. And then we just use the P matrix environment again to create our vector, but instead we don't really need to be horizontal. We just go vertically, so we just add backslashes to show that we're going down the vector. Next, for integrals, so I kind of chucked in a lot of expressions into this to try and get as much variety in it. It may not be a legit integral, but just an example. So again, we have \int to get the nice big integral sign. I don't really like the one in Microsoft Word. It doesn't look very nice. The fractional environment, fraction, 3x cubed, square root, that's square root to get the square root again, curly braces to get it over the whole expression. And I have 4 minus sine cubed theta. Notice I have a backslash behind the sign. If I don't have the backslash there, it is going to be ugly. It's going to be italicized. It's going to treat it as text. So what we do is we add a backslash to tell LaTeX that it is the mathematical sign function that I want to use, and it will change it to that nice looking one. Like so. To get the theta, we use backslash theta. And then to get the time symbol, we use backslash times. And then the exponential e to the power of, again, curly braces, ln x, using the backslash here again to not make it interpreted as text, just regular text.
Should you go through bounds as well?
Pun?
Like bounded, it's like lower upper bounds.
Lower and upper bounds?
Yeah. Like just like integral from like a to b.
Oh right, okay, good point. So to get the limits, or to get the powers, or you don't have to add powers like in this, right? Using the upper arrow thing. Similar with the integral, we can add the upper bound by doing upper number, say b, okay? You get the lower bound by doing underscore. Underscore is typically used for subscripts as well. So if we do underscore a, we're going to get integral from a to b. Okay? You can also do this similarly with like your regular terms as well, not just with integral signs. You can do maybe subscript, I don't know, y. Okay? Now, it looks kind of confusing with the underscore y to the power of 3. That's why I like to use curly braces to really show that I'm, to really tell me what I'm putting in the subscript, what I'm putting in the subscript, to make it a lot more clear. Okay? But it's not really necessary if you're working with single character terms. It's not necessary. And at the end, I put a backslash comma here, just to increase the spacing between the expression and the tx, because it looks a lot nicer that way. And full stop here, and just formatting. Next, trigonometric formulae. So, again, it's just like the previous one, I add a backslash in front of it in order to get the nicer version of the expression. Difference is that in LaTeX, or in most mathematical texts or typing things, they don't accept cosec as an actual trigonometric term. You have to use CSC. Okay, so if we were trying to use cosec, it's going to come up as an error because this does not exist. Okay, you can't type this up. It's only CSC x in LaTeX. Also with inverse functions, inverse trigonometric functions, there's no specific code for that, but you can use backslash sign to the power of -1x, just to show that it's an inverse trigonometric function. Or you could even use, if you've heard of it, using arc sine x or whatever, and that would be perfectly fine as well. Oops, maybe I forgot the code for it, but add a space there. Because sometimes in LaTeX, if you add an extra term next to the code, it's not going to register because it interprets the whole thing. It's going to add spaces just in case it interprets it as one. So next thing, we're going to look at summations and limits. So for limits, we just use backslash lim. Use the underscore to signify we want to go underneath the limit, to specify what it is. So in this case, we have n2 to get the right arrow, infinity. We have sum, using the sum function. Again, to underscore to the power to get the limits, the sum. And the fraction to just get the fractional term. Are there any questions so far? Anything you guys want to go through? And talk about anything?
How would you number the equations?
Number the equations? Yeah. Good question. Say I go back to my my aligned environment, yeah? What the star basically does is the star tells it not to have any numbers. If I get rid of the star there, I get numbers. Okay?
What if you want to number just one of them?
Numbers, one of them.
Tag.
You can use tag. So tag is another, tag would let you basically add a bracket to the right of expressions. Say I bring it back to what it was usually, like normally like this. Say I wanted to add an explanation, or even add like an equation number to the right of any one equation. Say it was the last line maybe, okay? I can add to the right of it, backslash tag, and typing something in here will get me some term, the expression on the right. So maybe this is the solution, or whatever. Or in the case of numbering an equation, you can just add 1. And compiling it again. Get that. Yeah? Anything else? Yeah?
You can put this code like online or something.
Yeah, well, often. Yeah. Really, if you can really read through code, understand what I'm doing every single step, you can type up a very basic LaTeX document that will, or if you know all these things and it's a little bit more, you can basically type up every LaTeX document you need to worry about in second year and beyond. Or if you want to get more fancy, there's a lot more code you need to learn. Yeah?
Is there a way to import a figure?
Import a figure?
Yeah.
That's what I'm going to do next.
Oh,
So,
great.
putting an image in your document. So this is where the that graphic X package comes in, where I loaded in the very beginning of the document, the preamble. So scrolling down, I now insert an image. In this case, it is the MathSoc logo. Or the, yeah. So inserting images, I like doing it in two different ways, or basically the same function but in two different parameters. First one is, you always start off by doing \include graphics to tell LaTeX you're going to start including an image. Okay. And then in the square braces, you have options. I'll go through that in a bit. In the curly braces, you want to define your image. Okay. Now defining your image, it's really hard if your image is in a separate folder. It gets annoying. You have to specify where it is exactly, or it might get a little bit difficult. What I like to do is I like to put the images I'm working with in the same folder and label it as like 1, 2, 3, 4, 5, etc. Because it makes it a lot easier to label your images, a lot easier to refer to them. So in the case of this, labeled my image 1. So you don't really need the file extension in stating the file in the code. You can just say 1, because LaTeX will automatically try to figure out what kind of extension it is and try to import it in. So ones that I've known to work are like PNG, JPEG, PDF, and there's so much more. I haven't really tested it to see what it is. I've tried Googling, but I haven't really come up with any results, but it accepts most common file formats, I think, which will be fine. So if you were to get rid of the option and load it like so, you will see that it's kind of big. It just loads the image like it is. But you can also scale it, or you can change the size of it by using the options. That's what I'm doing with the square braces. So there are two options I like to use. The first one being width, because width allows you to specify how wide it's going to be overall. And the one that I like to use is text width. So it scales it according to the text width on your page. So like the text begins at some point, it ends at some other point, and the image is going to go from those 2 points. Cover the whole page basically. It'll like it fits in, it'll be centered and whatnot. Okay. The second one is scale. So the scale basically does increasing or decreasing the size of the image by a factor. So in this case, I'm halving it, and so once we compile that, so it turns out something like this. And notice how it's not really centered, and that is because I haven't centered it. But the top one is centered because it covers the whole middle text width. That's what's in the center. The second one isn't because it's simply scaling it. But you can also center it using the center environment. Okay? So center environment. Let's do this. Begin center, and the center. Notice how it's American as well. Careful with that. Yeah. So next, to learn more, or like, if you start typing up code and you find you run into things that you want to do, but you don't know how to do them, really the best way is to Google them. That's the way that I found out most of the code that I know now. Is Googling what I wanted to do, learning the code from what people said, what people state and whatnot, and it's really helped a lot. But another thing that I've come to realize now is that everything you need to support maths is basically in the AMS math package. So what you should be doing is going to that package, opening up the documentation, and then going through it, finding what you want and reading through it. It shows you the best ways to type up certain mathematical equations and certain expressions and whatnot. So that's what I recommend you guys to do if you ever look for something, but if you ever want to look for something but you don't know where to find it. To the people who are more comfortable using LaTeX, there are two, well, in my experience, like I'm not a professional LaTeX typist. I just know the basics and what will help you get through everything you need to do. And two things that I've found out, two things that I've realized that would really help my typing with LaTeX was using something called new command and something called ticks. So new command basically allows you to define new, I don't know, like, how do I say this? So maybe in a math environment, I want to type up, like, in brackets, x squared plus 1 it gets really hard to track, right? Well, I'm having trouble here, but hopefully this compiles, and I'll show you what I mean. Okay, I'm forgetting something, the curly braces here. So it helps a lot having the highlighted part. See exactly what I'm missing. Nice, good expression, but this is quite tedious. Using view command, I can define a command such that using just maybe this, I can get my left bracket and right bracket all in one go. Okay? So in this way, it kind of fast tracks your LaTexing, your coding, that you don't need to worry about, oh, backslash left, backslash open bracket, backslash right bracket. You can just do one expression and cleanly add brackets to your code. This is something that you can try to figure out if you Google new command, try to figure out how to define these commands in your code in order to use them. So this just makes it easier to type up brackets and less effort in typing your code. The second package that I recommend is called TIX. Now TIX allows you to draw crisp, sexy pictures. By that, I mean like, you know those like graphs and circles and whatever in like basic documents? All of those can be drawn really well in TIX, but it's just, the only problem is TIX is a bit of a pain in the ass to use. Like, there are so many ways to use TIX that it can get quite confusing, but I guess it's really to learn how to use TIX, it's really just Googling what kind of thing you want to draw, then learning from some other code. So you can always deduce how to draw something by looking at someone else's code, and you can figure out how things work from there, and learn how to draw different graphs and whatnot. Okay. Any questions? That's really all I have planned for today. If you guys have any questions for what else you want to learn how to do, I can maybe show you if I know how to do it. But yeah. Woo! Okay. Is there anything you guys want to go through? Or anything you guys want to look at?